adventures of Math Girl. With the help of Pocket Ronnie, you also can become a trusty sidekick of Math Girl like PreCalculus and the Daring Derivative.
Okay, now we're going to be doing polar graphs. So we're going to take these polar equations and we're going to graph them. So let's look at 17D7. Okay, I'm usually going to tell you in advance what the shape looks like on the graph. So right now I'm telling you it's a line. There are two different ways you can tackle these polar equations to graph them. Either one, you can change them into a rectangular equation and then graph it if you recognize it's a line, it's a circle, it's a parabola. Some of these aren't any of those. Some of these are just special shapes. Or two, you can calculate and just plot values for r and theta, just like we used to make a XY chart when it was rectangular coordinates. You can do the same thing for r's and theta. You would basically pick values for theta and then calculate the r's. I'm going to do it both ways. So on 17D7, I'm going to change this into a rectangular equation. Okay? So I can see that if I multiply cosine theta plus sine theta to the other side, I'll be able to distribute this r, and then I'll have an r cosine theta and an r sine theta. Okay? So I'm basically multiplying by the denominator to get that out of the denominator, so that goes away. So then this side I have to multiply by cosine theta times plus sine theta. So I basically have r times cosine theta plus sine theta equals 6. Well, this r can get distributed. So I have r cosine theta plus r sine theta equals 6. Well, when I see r cosine theta, I can replace it with x. R sine theta, I can replace it with y, equals 6. And that will be a line. And then we can take this and go graph it. Okay, we're graphing 17D7, and I had told you it was a line. Here was the rectangular equation that we came up with. So just to show you on each one of these polar graphs that you have a horizontal line and a vertical line which can represent the x and y axis. Okay, so if you change it into rectangular coordinates, you have these. You just kind of have to do guidelines of where your tick marks would be. But the easiest way to do this equation of x plus y equals 6 is what happens when x is 0. Okay, so when you let x equal 0, when that goes away, y will be 6. Okay, I'm sorry. When x is 0, y equals 6. That's a 6. So when x is 0, don't go anywhere in the x direction. Go up 6. Literally, I'm counting those circles. 1, 2, 3, 4, 5, 6. Okay? This will tell me where I'm crossing the x and the y axis. So when y is 0, if that was 0, then x is going to be 6. So going 6 in the x direction, 1, 2, 3, 4, 5, 6, and y is 0, so I don't go anywhere in the y direction. So when you let x and y each equal 0, you're basically determining where you're crossing the x and y axis. You can do that for any line, because you only need 2 points to draw a line, and so therefore there's your line for that original polar equation that we had. Okay, now looking at 17D8, r equals 5 cosine theta plus sine theta. I'm going to do it just by calculating r's. I'm going to pick values for r and theta. So I'm picking values for theta. So I have r and theta. So you pick the values for theta, and then you are calculating r. Okay, so the theta is what you're picking. So basically I'm going to pick 0. So I'm putting in 0 right here for theta. So essentially I have r equals 5 cosine of 0 degrees plus sine of 0 degrees. When you do all that, r comes out to be 5. Because cosine of 0 degrees is 1 and sine of 0 degrees is 0. Okay, now what if I picked 180 degrees? And since your graph is labeled by radians, I'll just put that there. 180 degrees is pi. So essentially I have r equals 5 times cosine of 180 degrees plus sine of 180 degrees. When you go through those calculations, you come up with a negative 5. I'm going to talk about the negative values when we're on the graph. But the one thing I can tell you right now is that you don't want to have negative values for r. you want to find the values. You want to pick thetas to where when you calculate r, these all come out to be positive values, and I'll explain that why when I'm graphing it. Okay? So, what I found is that everything above 90 degrees was going to give me a negative value for r, and that's just by trial and error of trying to find where these values are going to make this negative. Okay, so I did use 90 degrees, which that is the same thing as pi over 2. So when I go plug in 90 degrees here and here, I had a r value of 1. I will write that out. That was r equals 5 times cosine of 90 degrees plus sine of 90 degrees. And that came out to 1. So then I picked 45 degrees. Okay, that's the same thing as pi over 4. And when I did that, then I'm just rounding to 1 decimal. That came out to r was 4.2. So then I picked negative 45 degrees. Remember, negative means going in the clockwise direction. So negative 45 degrees, which is also the same thing as 315 degrees, which is also the same thing as 7 pi over 4. So I recommend using 315 degrees in your calculations. R equals 5 times cosine of 315 degrees plus sine of 315 degrees. And when I did that, I came out to 2.8. Then I chose 60 degrees, and this just takes practice. I can't tell you exactly which degrees to pick. I can give you a guideline. I normally start with 0, 90, 180, 270. Those are all on the axis. Then in between, I'll pick 45, 60, 30. Pick the degrees on the axis, and then pick your special angles, 30, 60, 45. So 60 degrees, the same thing as pi over 3. And when you put that in, I came out to r was 3.4. Then I also chose negative 60 degrees, which is the same thing as 330. So when you're doing your calculations, use 330 degrees in your calculations, which that is also the same thing as 5 pi over 3. Because that's going in the clockwise direction, and when I did that, I came out to 1.6. Okay, now we're graphing 17D8, and I forgot to tell you that this was an ellipse. How many points do I need to calculate? Well, you need to do as many points as it's going to take to figure out what the shape is going to be. Okay, so there is no set amount of the number of points to do. So let's see, I did, that one doesn't count, 1, 2, 3, 4, 5, 6, 6. So I probably would recommend at least 6. So plotting this first point, when theta is 0 at 0 degrees, so here is 0, so at 0 degrees, that I didn't go anywhere in any of my degrees, then my r value is 5. Right here at 0, I need to count out 5, those little 5 circle rings. 1, 2, 3, 4, 5. That's how you plot that point. Then just let me do 90. So at 90 degrees, so here's 90, pi over 2, I have it in radians. At 90 degrees, so I am going for this vertical right here, I need to go up 1 ring. So at 90 degrees, I'm going to be right here at 1. Right there. 180. So here's 180 is a pi. So at 180 degrees, I need to go out negative 5. What does that negative mean when you're talking about radius? It means the opposite direction. All of these, counting out these circles, are positive radiuses. If I want to go negative 5, I'm going in the opposite direction. So instead of going at 180 degrees, I'm going in the opposite direction of 180, which is back over here at 0. And going out 5 would put me back to this red point that I already have. This is why you don't want negative values for r. You only want positive values. All of these rings represent positive values. That negative means go in the opposite direction that you're at. In other words, if you're at 90 going in the opposite direction, you're going to hit 270. So you don't really want negative values. It gets too confusing graphing. So let's go at 45 degrees. 45 degrees is pi over 4, so I'm along this line right here. So at that pi over 4 line, I need to count out 4.2 circles, okay? So that would be 1, 2, 3, 4, and a little bit more than that. Okay, that's close enough. So on the pi over 4 line, I went out 4.2 circles. Okay, now I'm going negative 45, which we said that was 315 degrees, which is 7 pi over 4. So 7 pi over 4, I'm on this line right here. I need to count out 2.8 circles. So starting here, 1, 2, almost 3. That would be about right there. Almost 3 circles. Now I'm at pi over 3, 60 degrees. That's up here along this line. I need to count out 3.4 circles. So 1, 2, 3, a little bit more than that, along the pi over 3 line. Okay, now negative 60 degrees, which was the same thing as 300, which is 5 pi over 3. So here's my 5 pi over 3 line. I'm going to follow this line, and I need to count out 1.6 circles. So starting in the middle, then I'm going to count out 1, and then, 1, so that's going to be somewhere right in there. And I told you it was an ellipse, so then is this enough points to try to connect everything together? So then connect your dots, and you can do the best you can, so to be an ellipse.